Hello guys, this is Prime Concept. In this video, we want to continue on our topic waves. But in this video, we'll be looking at wave motion. Now remember in our previous video when we introduced wave, we mentioned that wave is a movement or a travel of disturbance. So wave is a disturbance that is set on a material that travels from one point to another. Now when wave is set up on any material, you would notice that two things would usually happen. One is that the wave itself, the disturbance itself, would travel along a particular direction, and the particles of that medium would also move or vibrate around a particular direction. Say, for example, you tie a rope at two ends. You tie a rope like this at two ends, and you vibrate this rope. You pluck it. Say, I mark a point like this, and I vibrate this. This is what you would notice on that rope. You notice that the rope would begin to vibrate like this. It will begin to vibrate like this, and you notice this is the particle, the point I marked, which represents a particle of this rope. So you will notice that this point will just be going up and down, up and down. Now, while the wave I set up at this point, you notice is traveling forward. The wave itself or the disturbance is going forward, while the particle itself is just going up and down, right? So the movement of the wave itself and the particle of the medium is what we call wave motion. So we want to look at the kinds of movements we can have. We can have a case where the wave itself would travel forward, and then the particles will travel up and down, would vibrate up and down, not travel. We can have another situation where the wave would travel forward, the particles would also vibrate front and back, right? So this would now give us the two types of wave motion. So wave motion is of two types. So there are two types of wave motion. So number one we want to consider is transverse wave motion, right? So that is number one. What is transverse wave motion? Transverse wave motion is a wave motion whereby the displacement of the particle or the vibration of the particle and then the displacement of the wave itself are perpendicular. So transverse wave motion occurs when the particles of the medium vibrate in a direction perpendicular to the direction of travel of the wave. So in this case, you have a perpendicular relationship. So that is transverse wave motion. That is to say, if your disturbance is going forward like this, is going like this and is moving forward, your particles will just be moving up and down, up and down. So if you watch this, you'll notice that the displacement of the particles, and then this is the disturbance. This is the disturbance, which is the wave. So the displacement is what? 90 degrees. So whenever you have this kind of situation, the kind of wave motion you have here is what we know as what? Transverse wave motion. Now, what are examples of transverse wave motion? An example would include wave on a string. If you pluck a string like a guitar string, I have a guitar, assuming it was closed, I'll bring it. Now, when you pluck a guitar string, you would notice that it will be vibrating, it will vibrate sinusoidally. Now, you notice the particles will be jumping up and down while the disturbance travels forward. So, an example of transverse wave motion is wave on a string. Another example would be water wave. So, if I release a stone inside the water, you notice that the disturbance would go up, right? The disturbance will just go up and down while the particles will go up and down while the disturbance will spread in a spherical form around, right? So that relationship is also transverse, right? We can also have wave on a rope. So if I pluck a rope, it still gives us transverse wave motion. So I mentioned waves on a string, wave on a rope, water wave, electromagnetic radiations also follow this transverse wave motion. For electromagnetic radiations, you don't have particles that are vibrating. Unlike these ones for strings, for rope, for water, you have particles. For electromagnetic radiation, you don't have particles. What you have is the electric field travels in a direction perpendicular to the magnetic field. That is why we say electromagnetic radiation is also a transverse wave motion. Let me illustrate it with a diagram. For electromagnetic radiation, this is what you have. This is the direction of travel of electric field, which I can illustrate with line like this. This is the electric field. It travels in this direction forward, right? It travels along your y-axis, like you can see. Then the magnetic, this is E. Then the magnetic field travels in this way. Travels in this way. Like this. So this is our magnetic field, like this. So you notice that the relationship between both of them are perpendicular to each other, right? So that is for electromagnetic radiation. Electric field and magnetic field are perpendicular, so we say they still fall under the transverse wave motion. Now, number 2 type of wave motion we have is our longitudinal wave motion, right? Longitudinal wave motion is a wave motion where the direction of travel of the wave is parallel to the vibration of the particles of the medium. For longitudinal wave motion, the wave travels parallel to the vibration of the particles of the medium. So you have a parallel relationship for longitudinal wave motion, while for transverse you have perpendicular. Now, what are examples of longitudinal wave motion? You would have your what? Sound wave. Your sound wave is an example of longitudinal wave motion. So I'm going to stop this video here. In my next video, I'll be analyzing the characteristics of wave. Now, what you will do for me is I just gave one example of the longitudinal wave motion. I want you to drop, this is one. I want you to drop 2 more examples and make it 3. Drop 2 more examples on the comment section if you understand what I've explained about wave motion. Thanks for watching my video. Remember, this is Prime Concepts. If you are yet to subscribe, you may not see my video after this, so do well to subscribe so that you can be getting notifications on my video. Thanks for watching Prime Concepts.